Planting trees is a widely accepted way to reduce the carbon dioxide concentration in the atmosphere. And although most of us learned in high school biology that plants in the presence of sunlight and chlorophyll convert CO2 into sugars and other carbohydrates, this is a very complicated process. But one of the most important pieces of information to support the idea that we should plant trees comes from the work of Charles David Keeling, after whom the Keeling curve is named. Keeling's advance, which was touted as one of the great advances of the 20th century, was to develop methodology that allowed him to measure the CO2 concentration in the air at relatively frequent intervals. And when he started doing that, he noticed several things. First of all, the CO2 concentration was rising gradually, and on a regularly predictable seasonal basis, there were fluctuations in the CO2 concentration shown by this inset. Now, subsequent work has shown that the period during which the CO2 concentration falls is due to the growth of trees and other woody plants and leafing out of these plants in the northern hemisphere. Similar findings have been recorded in virtually every other lab in the northern hemisphere that's looked at this. In the southern hemisphere, the response is a bit more blunted because there are fewer trees in the southern hemisphere. So let's look closely at the kinds of trees that we might be talking about. Trees capture CO2, and here's one kind of stand of trees, the so-called boreal forests. These grow in northern Canada, Siberia. In boreal forest tree, seeds fall to the ground and they either sprout and grow into new trees, or they get eaten, or something else happens to them. The bottom line, though, is that they require no or receive no attention from human beings. This is in stark contrast to the urban forest, which is the kind of forest that all of us have on our Kendal campus. And this is a maple tree on the campus of Kendal at Oberlin. These are not naturally occurring trees for the most part, and they require quite a lot of attention from we human beings. And almost invariably, this attention causes the emission of carbon dioxide. So to get a true look at the CO2 balance that's achieved by planting trees, you have to subtract the amount of CO2 that's emitted as a result of cultivating that forest from the amount that is captured by the trees as they grow and prosper. Now, this problem has been studied quite intensively by David Novak, who's a retired Forestry Service employee who's written several articles on this topic. And not surprisingly, his group finds that the amount of CO2 that's sequestered depends on the size of the tree at maturity, its lifespan, and its growth rate. And it's also worth noting that about 25% of the CO2 that's sequestered is below ground. Now, compare this with the carbon dioxide that's released into the atmosphere, almost always by burning fossil fuels for the maintenance and planting of trees. So this occurs as you operate a chainsaw and other pruning equipment, as trucks drive to deliver trees from the nursery or the planting site to the site where the tree is put in the ground. Stump grinders that deal with unwanted stumps at the end of the lifespan of a tree, chippers that chop up branches and the like into mulch, the preparation of fertilizers, pesticides, the use of mulch versus putting tree trimmings in landfill, and last but not least, construction of adjacent properties or construction of the site at which the tree is planted, all reduce the impact of CO2 sequestration by trees. So Novak and his colleagues developed this principle they call the last positive point, LPP. And the last positive point they define as the number of years when the total carbon emissions becomes greater than the carbon sequestered. And this varies, as I said before, according to tree species maintenance activities, disposal and utilization of removed species, and so on and so forth. The greater the LPP, the more beneficial the tree is at sequestering carbon. So to maximize the impact of a tree that you might want to plant in an urban forest, you should choose trees that have high LPP values. So to illustrate some of the things that detract from the sequestration of CO2 by trees, take a look at these pictures that I took all on the same day as workers were planting a new entryway to the Heiser Community Center here at Kendal. And at this top image, we see a diesel truck that's full of mulch, a cement mixer, which is a diesel-powered truck that's full of cement, and cement is one of the most CO2 intense industries in the United States. There's also reinforcing bars and reinforcement for the concrete that they're pouring, also a CO2 producing activity. Behind this tree here, you can't see it, but there's another truck that's pulling a trailer. This is our mail delivery service. Here's another truck pulling another trailer, yet another truck that's a panel truck that pulls equipment, and really difficult to see, but there's yet another truck hiding behind here in the distance. Now here's another view from the other side. Here's the two trucks, our mail delivery folks. And here are the workers that are working to plant the new trees and shrubs around the entry. This is the foreman. You can tell the foreman because he's the one who doesn't appear to be doing any work. And here are the workers in the background digging holes, doing things that are relevant to planting the tree. Down here in this bottom panel, you see another worker and yet another one who's astride a device that is burying irrigation pipes. These are PVC pipes, another petroleum product and a CO2 producing activity. And of course, this is a diesel powered device. There's a lot of energy that's going into planting these new trees. And last but not least, here's a mountain of mulch, as some refer to it, at least 4 or 5 inches of mulch, which will decay, producing methane and CO2 that goes up into the atmosphere. So there's a host of CO2 producing activities here all in one time that diminish the impact of the CO2 sequestration that's taking place in the trees that are being planted. So here at Kendal at Oberlin, we have developed what I refer to as sort of a climate responsibility corner of the campus. This is a photograph of one of the new garage complexes that was just completed. And atop the roof of this complex, which is facing south, is an array of solar panels. And this is the solar panel array on the garages that face this across a parking and driving area. So the electricity that's generated by this solar array is being sent out onto the grid and is estimated to be about equivalent to the amount of electricity that will be required to power a new generation of outdoor lights that will be surrounding the perimeter walk and drive of Kendal. Now, included in the new garage complex is a total of 3 electric vehicle charging stations. And here's one of them. This is a 240 volt, 50 amp electric service connected through this cable to an electric vehicle. And there are 2 others in this complex. If your electric vehicle fails for some reason, here's the backup in the background, a bicycle. So immediately behind the new garages, which are up here in the upper left-hand corner, are a series of trees that are either already in existence or on tap to be planted at the next planting cycle. The first of these is a sweet gum tree, and this is the Champ LPP tree in this array. It has an LPP value of 960. New to the site in the next year will be a tulip tree and 3 white oak trees. Each of these have LPPs of 720, just a bit below the sweet gum. Here is a red maple, one of the most common trees on our campus. It has an LPP of 360. And this is a river birch, also a common tree on our campus. And it sort of brings up the rear in terms of the value of this as a carbon sequestering species. It has an LPP of just 60. So here in one spot, an observer would be able to stand here next to the roadway, see this array of trees in our urban forest, the new solar arrays that are installed, which hopefully will be transmitting information about the power generation to a TV set in the lobby of the Heiser Community Center. So people who don't live around our neighborhood will be able to see the benefits of the solar power array as it works on a day-to-day basis. So there you have it in a nutshell, urban forest versus boreal forest and the value of trees in sequestering carbon dioxide.